right, class, today we're going to talk about chapter 10, which is all about linear regression and correlation. So that's two new terms right there. Let's go ahead and figure out what these mean. So, why would a statistician use linear regression? So, often we want to know how two or more variables are related, right? How does the cost of gasoline change over the course of the year, right? Gasoline tends to cost more around the holidays, during the summer when people are traveling, right? What I want to find is there a relationship, for example, between the grade on the second math exam a student takes and the grade on the final exam, right? And if there is a relationship, how strong is that relationship? This type of data I described is called bivariate data, bi meaning two variables. In reality, statisticians use multivariate data, multi meaning many variables, but in this chapter, we're going to be looking at linear regression with two variables. So we've got our independent variable, x, and we have our dependent variable, which you guessed it is going to be y, okay? And this involves finding data that fits onto a line, right? When we have a coordinate plane, we graph a line in terms of x and y, okay? So we're going to study correlation and how to measure how strong the relationship is between two variables. So what is linear regression? So linear regression is finding the equation of a line which best fits our data, okay? We've got our independent variable x and our dependent variable y, and the equation will have the form y equals mx plus b. Now you might remember this from intermediate algebra or college algebra, right? This is also called point slope form. Nope, this is called slope intercept form. Good morning, Miss Miller. Right? And that's because m represents our slope and b is our y-intercept. So this is slope-intercept form of the line. Remember that slope can be positive, such as in example A, negative in example C, right? It's going downhill. Or I can have zero slope, okay? So this would be m equals 0, m is negative, and m, our slope, is positive. So the graph of all linear equations is a straight line, okay? This does not include vertical equations. Vertical equations have the formula x equal to some c, which is a constant, and we aren't going to worry about those. But just in case you forgot, these have undefined slope. So let's remember how to use a linear equation, because college algebra and intermediate algebra might have been a few semesters ago. So I want to assume that the best fit line for a set of data that compares the heights of males in inches, so that's our x variable, to the weight of males in pounds is given by the following equation, y equals 2x plus 10. So I want to find the weight of a male who is 64 inches tall. So I'm going to take y equals 2x plus 10. This is my equation. I know that my x variable is male's height in inches. I'm given a height of 64 inches, so I'm going to use substitution to plug that in for x. So I have y equals 2 times 64 plus 10. That's going to give me 2 times 64 is 128 plus 10. So based on this data set and our best fit line, the weight of a man who is 64 inches tall would be 138 pounds. Now, what if I want to use this equation to find the height of a male who weighs 120 pounds? Tiny typo right there. Okay, so I have y equals 2x plus 10. But this time I'm not given the height, I'm given the weight, which is our y variable. So I'm going to substitute in for y and solve for x. So first thing I'm going to do is subtract 10 from both sides. That gives me 110 equals 2x. I divide both sides by 2. That's going to give me x equals 55. So for a man who's 55 inches tall, we could expect him to weigh 120 pounds. So this is how we use linear equations. This should be pretty familiar from your previous math course. Now, what if I want to find the linear equation? What if the linear equation is not given to me? So let's read this word problem and break it apart. So Aaron's word processing service does word processing, okay? The rate for services is $32 per hour plus a one-time charge of $31.50, okay? So the total cost to a customer depends on the number of hours it takes to complete a job. So find the equation that expresses the total cost in terms of the number of hours required to complete the job. So the total cost is going to be our final value. It's dependent on how long it takes, right? How many hours. So this is going to be our y, and the number of hours is going to be our x. So I know my total cost is going to equal $32 per hour, so 32 times x, plus a one-time fee of $31.50, right? That's my y-intercept. This is my b, my y-intercept. So here we have the linear equation that represents this word problem right here. Let's take a look at that again. Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. A linear equation that expresses the total amount of money Svetlana earns for each session as she tutors is y equals 25 plus 15x. Okay, we'd normally write that like this, right? We like to have our variable before our constant. So what are our independent and our dependent variables? So remember our independent variables, x, that would be the hours she spends tutoring. Now, what's our dependent variable? Well, our dependent variable is the amount of money she earns for each tutoring session, right? The amount of money she earns depends on how many hours she spends tutoring. I combined like two words there, like spend students. What is this? Let's try that again. She spends tutoring, and y equals the total amount earned for each session. Now we're given the equation, so the next question I want to know is what is my y-intercept and what is my slope? Well, my slope is going to be my coefficient on my x, so slope, which is m, is going to be 15. This is positive slope. And my y-intercept is going to be my one-time charge, which is 25. So that's how we're going to work with linear equations.